So Bismillahirrahmanirrahim. In the second part of induction motor chapter, second video, so I'll continue with the next slide that explains on full load or rated condition. I'm sure I've explained this term to you guys during the second chapter transformer, because in transformer also we have full load and rated condition lah. So it's the same thing. So at full load condition, or the other name of it is rated condition or rated load condition, P out equals to P out rated. Okay, so if a machine is not operating at full load, not operating or not stated operating at full load or rated load condition, we cannot simply take or assume that P out is equal to P out rated. In other words, we have to find the P out used during that condition, because it's not the same as the P out rated. Okay. Just now, you've been in the previous video, you've been introduced with the equivalent circuit, approximate equivalent circuit of an induction motor. So that is the most important part. Second most important part is the power flow diagram. So I think this is the first time you've been introduced with a power flow. So the one that looks like fishbone there is called as power flow diagram. So it's not that complicated. So let me explain first. As you can see, it started with the main straight line or the main straight arrow that starts from P in and then goes to P out. Okay, so this is your P in, this is your P out. Theoretically, we want to deliver, or we want to convert your input power, that is electrical power, 100% to mechanical power at the output part. But because we are dealing with real induction motor, so we're going to have lots of losses. Therefore, we cannot convert 100% of your electrical power into mechanical power. Instead, we have losses. So all those losses are represented in the downward arrow down here. 1, 2, 3, 4, 5. So we have 5 main losses in induction motor. Okay, that is number 1, PSCL. Okay, PSCL is stator copper loss. Okay, that is losses at R1. Okay, and then we have core losses at your RC, and then we have also rotor copper loss. Don't worry, the full name of each loss are stated in the next slide. Okay, so PRCL stands for rotor copper loss. That is the losses due to the heating on the rotor dekat R2. Okay, and then we have mechanical loss and stray loss at the end. Okay, before that, why do we start with stator and core and end up with rotor towards the output part? Because your input power, electrical power, is injected into stator. Okay, remember, we inject electrical power on stator, and then our mechanical power is produced on rotor. So that's why stator on the input starting, rotor on the output. Okay, now mechanical loss. Why mechanical loss is stated towards the end? Okay, from the word mechanical, anything that is related to moving part is called mechanical, right? So Your output is on your rotor. Rotor is rotating. That's why we have mechanical loss at the output part. Okay, and mechanical loss is divided into two: rotational loss and frictional windage loss. Okay, last one we have stray loss. Okay, the explanation of H loss will be stated in the next slide. Okay, but I just want you to understand how the power flow works. Okay, so the arrow downward are your losses. So what is the dotted line then? So on the first dotted line is the air gap power, PAG. That is losses at your R2/S. And the second dotted line is your converted power, P converted. So that's the formula. Okay, so the formula for input power is given as 3 VT phase I1 phase cos theta. Why VT phase? Because your input is on the pre-phase terminal voltage here. That is your VT phase. And your input is I1 phase. That's why to calculate input power, we multiply 3 VT phase I1 phase cos theta, or if you want to use line value, because we know that this is a 3-phase machine, you can either use line or phase value. So similar to chapter 1, the formula is square root 3 VT line I1 line cos theta. So theta is given as the difference of angle between VT phase and I1 phase. Alright, so that is your input. That is the formula. Your input you electrical, right? So your output is mechanical power. So mechanical power, the formula is no longer 3 V phase I phase cos theta. Instead, the formula becomes P equal to torque times synchronized speed. So for P out equals to load torque or output torque times omega m is the motor angular speed. Okay, remember we have two speed, synchronized speed and motor speed. So why do we use motor speed in the output power, the formula for output power? Because our output is on the rotor. So the speed of the rotor is also called as motor speed or rotor speed. Okay, your output is on rotor, so that's why we use omega m here. Now, how do we use this power flow diagram? So just now I said, if you, for example, if your input power is 100 watt, you want to convert it into 100 watt also at the output, but that is not going to happen because we have all the losses. So let's say each loss here, the value is 2 watt. So this is 2 watt, 2 watt, 2 watt, 2 watt, 2 watt. So altogether 10 watt, right? So your input is 100 watt. So minus 2 becomes, so you want to convert 100 watt. Okay, and then at this point 2 watt has lost. Okay, so at this point it becomes 98. And moving forward, oh, you have core loss. So another 2 watt is lost. So it becomes 96. So moving forward, so at this point we can say that your P air gap now is 96 watt. Okay, moving forward, you have another 2 watt PRCL 2 watt, your loss. So 96 minus 2 moving forward, you are only left with 94 watt. So P converted U is 94 watt. The value of power left at this point of P converted U is 94 watt. Moving forward, so you have mechanical loss, another 2 watt. Okay, so you have lost another 2 watt, so you are left with 92, isn't it? 92 watt. Okay, moving forward, P stray lost another 2 watt, so you are moving forward, you are only left with 90 watt. So that is your PR, 90 watt. Instead of converting 100 watt into mechanical power, the amount of output power delivered to your load is only 90 watt. So that is what power flow tells you. These are the losses, and P air gap and P converted is the amount of power left at that point lah. Okay, so in terms of the formula, just now I explained to you the formula for input and output.